Welcome back, my viewers. Gay-Lussac law is one of the laws of gases. Talking about the gas law, the Boyle's law, Sharp's law, Avogadro. Gay-Lussac is also one of them. Gay-Lussac is the guy that postulated this very law. And the question you are seeing there, this is a question that you likely see in your Jamb exam. It's always there. If you check your past question, if you are very frequent to your past question, you notice that this particular question always come out in most of the years. This particular question, they don't change the values, they don't change any of the parameters. This is how you are going to see the question if JAMB is going to set it for this very year. So now look up. The first thing you have to do, let me read. 30 cm cube of carbon 2 oxide, 30 cm cube of carbon 2 oxide. Carbon 2 oxide are sparkled with 30 cm cube of oxygen. If the volume of gases are measured at STP, calculate the volume of the residual gas after sparking. Now, the first thing you have to take note of is, what are the things reacting? The first one I can spot here, CO2, carbon 2 oxide, that's the CO, remember, is in gaseous state, plus are sparkled with 30 cm cube of oxygen, and let's try this and get our product. When CO reacts with this, our answer must be CO2. That's carbon monoxide plus oxygen is going to give us what's it called? Carbon 4 oxide. Now, if you look at this carbon 2 oxide and this oxygen here, tracing it to this place, it is non-balanced. We have 3 oxygen here and we have 1 here, 2 here rather. So what I'm going to do here is this. If I put a 2 here, we are going to have 2 carbon atoms here. Let me put a 2 here. We have 2 carbon atoms here, so my carbon is balanced. We have 2 oxygen, so we have 4 oxygen in this part, and we have 4 oxygen in this part. So this, my reaction, is balanced, and this is a reaction for the equation. Now, since you have gotten the reaction for the equation, what I'm going to do, I'm going to write the number of mole out. Let me bring my work to this side so that it will be more unique. So I have reaction, and my reaction is 2 molecules of carbon 2 oxide plus oxygen to give us 2 mole of CO2. Then number of mole, we have 2 here, we have 1 here, and we have 2 here. So please take note of this. Now, the volume of gases before sparking, that will be my next step. The first one is reaction, number 2, number of mole, then volume before sparking. Now, this is where most students get it wrong. Please take note. If an acid is reacting with a base, at the beginning of that reaction, there is no product. So if I say A plus B to give us C, what is the volume before the reaction? What is the volume of let's say, what is the volume of A before the reaction, or what is the volume before this reaction? Please, you are not to write any volume for this product, because at the beginning of the reaction you have not formed a product. So you can write the volume for A, you can write the volume for B, but there is no volume for C because you have not started the reaction. So please take note, you are not expected to write anything under the CO2. Remember, every chemical reaction we have the reactant and the product. The species that are reacting is called the reactant, and the species that is formed, we call that the product. So please take note of that. Then before sparking, I said 30 cm cube of oxygen. So I will write 30 cm cube here. Is there any other volume? Okay, let me read. 30 cm cube of carbon 2 oxide. Yes. CO are sparkled with 30 cm cube of oxygen. So I have 2 parameters here. We have this and we have this. So I'll write my 30 cm cube here, and here is unknown. I don't know it. So before sparking, from the equation, we realize that we got this for CO and this for oxygen. So please, that is the only thing you need to take note of. Then let's go to the next step. After volume of gas, after sparking, it wasn't given to you. It was not given to us. So what we are going to do is this. It's very, very easy. We are going to take 2 as 30. If 2 is 30, then, sorry, if 30 is taken as 2, then 1 will be taken as what? 15. Then let me come again. If you have 30 here and someone tells you that 30 is equals to 2, then I can also say 15 is equals to 1. And I can also say 7.5 is equals to what? 0.5. And I can also say 60 is equals to 3. So this is just the logic behind this whole stuff here. So what I'm going to do is this. We have 30 here and here is 2. So I'm going to bring 30 to this place. Then half of 30, remember here is 1. Here we are going to use 50 cm cube for the sparking. Then at the end we have 2 there. So what I'm going to do is I'm going to place a 30 here as well. Remember, wherever you see 2, you replace it by 30. 1 should be 15. 2 is 30. Assuming you have 3, you now replace it with what? With 60. So now let's continue with this. Let's subtract the volume before from the volume after. Let me put a minus here. If I should put a minus here, you are going to have 30 cm cube. That's after. Then here you are going to have 15 cm cube. Then 30 minus 30, you are going to have 0. So this is the volume of the residual gas after sparking. So what you are going to do at the end is just for you to sum your two products, 0 plus 15 plus 30 cm cube, and our answer will be 45 centimeter cube. So please take note of this. What you need to do is that the first thing, write the reaction for the equation, write the number of mole, the volume before sparking, the volume after sparking, and then you come back to this, which is the volume of the residual gas after subtracting this plus this to give you your answer. I want you to take note of this again. Before the reaction, the product have no volume. It has no volume. So it is after the reaction that is when a product can have a volume. So if you look at this, after the reaction, volume after sparking it was 30, then here is 15, and after sparking here is as well is 30. It doesn't affect anything at all. Just take note of these parameters here and then work with them. You can also pick other examples on this and see how far we can go. Thanks for watching. God bless you.